This is the day 19 video. If you notice, you already have all these notes. You should have all these notes written down from the other day in class, except for this last line right here. So you just need to maybe find those notes, maybe hit pause, find those notes, and we're going to add this last line. So with exponential functions, you could have a growth function or a decay function. Growth, obviously, we're growing, increasing, and decay, we are decreasing. Now, we need to be careful, but here, if a is greater than 0 and b is between 0 and 1, notice it's not equal to 0 and not equal to 1. And we talked about that last time. I'm sorry, we talked about it in class and in video day 17, I think, where if b equaled 1, this would just be a linear function, and if b equaled 0, it would also be a linear function. So we need to restrict b from being 0 or 1. But what if b is between 0 and 1? What if it's a fraction between 0 and 1? That's going to be a decay. So there are a couple ways of writing this, and I really like the way that the Khan Academy video does it. I have that posted right next to this. But he says, you know, before we talked about growth, right? Y equals 3 to the x. So a decay would be, for example, something like this, 1/3 to the x. So, but there's another way of writing this, 1/3 to the x. That's the same as saying 3 to the negative 1 power, and then multiply power to a power. Really, we can write this as 3 to the negative x. So this and this are equivalent. You can rewrite this with a negative exponent. So we need to be careful. Also, we can think of this as a growth function. 3 to the x power, right, is a growth function. It looks like this. And then if I put a negative here, really what that says is this is going to be a reflection over the y-axis. So here's my y-axis. This is my growth function. If it reflects over the y-axis, right, I'm reflecting it that way, then it turns it into a decay function. So we need to be careful of the negative and the exponent. But in general, when we're looking here and we have a fraction, we're going to, and this is positive, this is going to, I'm sorry, a fraction between 0 and 1, then this is going to be a decay function. Okay. So I want you to keep in mind, if you haven't gotten this down, this is the same exact process, right? So we're multiplying our stretch or compress to our y values because the stretch affects the y values, and then we're going to do our k is going to affect our asymptote, right? So we have our asymptote. It's going to be affected by k, but it's also going to shift all of our points up or down. And our h is going to move us right or left. But remember, we need to do the opposite. So here, x minus h. So here we're doing x plus h. And then these are the values that we're going to be graphing. All right. So let's go ahead and find how to find the y values here. All right, so let's start with a simple one. Y equals 1/2 to the power of x. So we are going to do this the same way. We're going to start with -2, -1, 0, 1, and 2. All right, so if I plug -2 into my parent function, here my parent function is 1/2 to the x power, I get 1/2 to the -2. Ooh, okay, let's figure this out. We got a negative in the exponent, which means we need to do the reciprocal, or I distribute that power to the numerator and denominator, and this moves up and that moves down, so we end up with 2 squared. So I do the reciprocal and that makes it positive, so then 2 squared, I get 4. I could do that better. 1 to the -2 over 2 to the -2. You could look at it this way and this comes down. 1 squared in the denominator and 2 squared in the numerator. So really that's just 2 squared. All right, so we get 4. So 1/2 to the -2 gives me 4. 1/2 to the -1 is just the reciprocal of that, which gives me 2. Anything to the 0 power, so 1/2 to the 0 power gives me 1. 1/2 to the 1 power is just 1/2. And 1/2 squared is the same as 1/2 times a half, which is 1/4. All right, so I've got my values 4, 2, 1, 1/2, 4. You might recognize this. The growth function had 1/4, 1/2, 1, 2, 4. So if you notice, now we're decaying, whereas before we were growing. All right, so let's go ahead and plot these points. Negative 2, 4. I have a nice big graph here. Negative 2, 4. Actually, I'm going to move this up so I can see it better. Negative 1, 2. 0, 1. 1/2. And 2/4. And again, I'm just approximating that 1/4. So we want to draw our asymptote, right? There was no shift in our k, so our asymptote is just y equals 0. We want to draw that and label it. And then we want to graph our function. So we draw a smooth curve. We're approaching the asymptote, but we don't cross it. And we put an arrow. This comes up here. And let's see, if I went to 3, it would be cubed, it would be 8. All right, so it grows very quickly, 8, and then it would be 16. That's kind of sloppy. I wish I was using pencil, right? Oh, man. I tell everyone to use pencil, and I use pen. All right, let me get an eraser. Okay. Anyways, it's going to look something like that. So it's a decay function. Again, it approaches the asymptote. We want to look at the domain and range. The domain of this is all real numbers, right? We're looking at which x values, and all real numbers can go in there. And the range is all y's greater than 0. Now again, we're not going to do equal to 0 because it's never going to touch that axis of symmetry. I said it again, axis of symmetry. It's never going to touch that asymptote. Wow, okay. All right, let's try another one. So now we have 1/3 to the x. I want you to pause, try it, and then see if you got the same thing. So go ahead and hit pause right now. All right, and this is what you should have gotten. Domain, again, all real numbers, and range y is greater than 0. So you want to see now that we have 9, 3, 1, 1/3, and 1/9 as our values. And we have this, oh, what did I forget? I forgot my arrows. Oh, I got this one here. Okay, so that is another decay function. All right. I want you guys to try the next one. The next one's going to have some transformations to it. So I want to get started on it, and then I want you to pause. So let's go ahead and identify what these titles are going to be. So right here, my first thing I want to do is stretch. So I'm going to stretch here by a factor of 3. So I'm going to multiply all my y values by 3. And then I'm going to add 2. So I take those 3 y values and add 2. And then over here to my x's, I'm going to not subtract 4, right? We have to remember x, the opposite. So I'm going to do x plus 4. All right, so these are my titles. It kind of gets me ready to do my transformations. Now what goes here is my parent function. Now again, how do I identify my parent function? I scribble all these out. I ignore this and I ignore that because I'm already taking care of that in the table. I just need to put my values for y equals 1/2 to the power of x right here. Okay, so -2, -1, 0, 1, 2. So I start with my parent function values and then perform the operation. So go ahead, hit pause right now. All right, to that one student who told me, you know, Miss McSorley, we're not actually going to hit pause. I need you to hit pause. Try it on your own because you need to get the feedback. All right, hit pause. So these are the x and y values that you should have gotten. You may have put decimals here like 2.75 or 3.5. That's fine. I prefer fractions for some funny reason. I don't know. So if you did not get these values, I want you to hit pause again and just double check. see where, if there were any issues, where that issue happened. Okay, so go ahead and hit pause again. I'm going to graph it and hit play. And that would be my graph. So I just want to look at this for a second. What were the transformations? I want to double check. Okay, I stretched by a factor of 3. I went up 2 and right 4. So I started here at 0, 1 was my y-intercept. I moved, well, let's take our asymptote actually. We moved up 2. Okay, my asymptote moved up 2. And then I moved right 4. 1, 2, 3, 4. And usually it would have been up 1, but it's stretched by a factor of 3. So it's up 1, 2, 3. It's stretched by a factor of 3. So we're good. All right. Let's see. Okay, domain and range. Notice the range changed. Range is y greater than 2. All right. And domain is all real numbers. I'm going to give you guys one more to try. Do I have another one? I do. Good. Okay. I want you to try this one. This one has a compression, but again, you're just going to do that, multiply it to the y's. Try this one, and then that will be good. All right. Hit pause, try it, and then check your answer. And this is what you should have. So you want to double check your values. Make sure that you did it in the correct order, multiplied and then added. In this case, my asymptote moved up 4. Right? So we have y equals 4 as our asymptote. All right. So make sure you write down any questions you have so you can bring them to class on Friday. All right. See you guys tomorrow.